Warm aluminium metal reacts readily with dry chlorine gas to produce anhydrous aluminium chloride. Here, when preheated aluminium foil is introduced in the jar of chlorine, it produces a white smoke of anhydrous aluminium chloride which sublimes slowly on standing. Gentle warming is sufficient for the reaction to happen. Strong heating leads to the formation of aluminium oxide layer which prevents the metal from reacting with chlorine. Hydrated aluminium chloride is often prepared by dissolving aluminium metal in the concentrated hydrochloric acid. Here I am dissolving 1 gram of aluminium metal in 9.3 milliliters of 37% hydrochloric acid. A slight excess of acid is usually added to dissolve undissolved aluminium as the concentration of the acid goes down slowly over a period of time. During this reaction, a mixture of hydrogen and hydrogen chloride is liberated as this reaction is highly exothermic, which boils the acid. If there are some aluminium particles remain undissolved, remove them by filtration. Do not boil the solution as it decomposes into alumina and hydrogen chloride. Hydrated aluminium chloride can also be obtained by dissolving aluminium hydroxide in hydrochloric acid. Take 1 gram of aluminium hydroxide and dissolve it in 3.2 milliliters of 37% hydrochloric acid. Aluminium hydroxide dissolves in hydrochloric acid with a fizzing sound to produce aluminium chloride. As I said in the previous method, even if it hasn't dissolved completely in acid, do not boil it as aluminium chloride decomposes on heating even in aqueous solution. This method is a less familiar method and an expensive one. Still, it is a quick way to make aluminium chloride. Take 9.5 grams of cupric chloride dihydrate and dissolve it in about 50 milliliters of water. Drop 1 gram of aluminium metal in copper chloride solution. This is a metal displacement reaction. Since aluminium metal is far more reactive than copper, it displaces copper from copper chloride solution. A spongy deposit of copper is formed during this reaction and it sinks down as the reaction progresses. The solution decolorizes slowly due to the formation of aluminium chloride. Pure anhydrous aluminium chloride is a colorless solid, but an old sample slowly turns pale yellow on standing. It is a Lewis acid. It fumes strongly in moist air as it reacts with water to produce hydrogen chloride. Here it reacts with water slowly. It is because if you don't use it for a long time, anhydrous aluminium chloride on the surface reacts slowly with moisture in the air on standing even if you close the container properly. To show how it reacts vigorously with water, I have taken some from beneath the surface. See how it reacts violently with water and liberates hydrogen chloride. This reaction is highly exothermic. For this reason, anhydrous aluminium chloride should be stored properly.